Welcome to Brain Vision.
We need to find the value of the force exerted at this point B, which I'll call as a force BD, and we also need to find the value of the force exerted at this point A, which I've called F of AB. And we're given by the problem that theta is going to be equal to negative 20 degrees, and I drew out this free body diagram with an unknown angle called phi, and unknown lengths, which we need to find to help solve this problem. And to calculate this weight at this point C, we use the formula weight is equal to mg, and we're given that the mass is equal to 200 kilograms. So we do 200 times the acceleration of gravity to get a value of 1.962 kilonewtons for W. So to start solving this problem, we're going to first start by solving for the unknown lengths in this free body diagram. So to find our length A, we can do 5 times the cosine of 20 to get a length of 4.6985 meters. To find our length B, we can do 2.4 times the cosine of 20, and this will give us 2.2552 meters. For C, we can do 2.4 times the sine of 20, which will give us 0.8208 meters. For D, we can do our length B minus 0.5, and this will give us 1.7553 meters. And to calculate length E, we do 0.9 minus the length C, and this will give us 0.0792 meters. So next we're going to find the angle phi. So this angle phi we'll calculate next. So to get angle phi, we can write it as phi is equal to the tangent inverse of 0.0792 divided by 1.7553, and we'll get an angle phi that is equal to 2.584084 degrees. So from the free body diagram, we're going to take the sum of moments at the point A using the information that we've calculated. So we take the sum of moments about the point A equal to 0, and we can write that as W times A minus F of BD times the sine of phi times B minus F of BD times the cosine of phi times C is equal to 0. So we plug in the known values and we solve for F of BD. So we plug in the weight W times the length A minus f of BD times the sine of the angle phi times the length B minus f of BD times the cosine of phi times the length C and set that equal to 0. So we take this equation and we solve for f of BD. And we'll get a force that is equal 10.003 kilonewtons. So we know f of BD, so we're now going to solve for f of AD. So to start, we can take the sum of forces in the x direction and set it equal to 0, which we can write as the x component of the force at point A minus the force BD times the cosine of phi is equal to 0. So we know f of BD, we know phi, so we can solve for A of x. So we have A of x minus the force BD times the cosine of phi is equal to 0. And solving for A of x, we'll get a value of 9.993 kilonewtons. So we now take the sum of forces in the y direction. So the sum of forces in the y direction is equal to 0. And we can write that as A of y minus w plus f of BD times the sine of phi is equal to 0. And we know w, f of BD, and phi. So A of y minus w plus f of BD times the sine of phi is equal to 0. And solving for A of y, we'll get a value of negative 1.5112 kilonewtons. So to get the force at the point A, we can take the x component and the y component and take the square root of them added together with each component squared. So the force A, that's going to be equal to the square root of A of x squared plus A of y squared. So you plug in A of x square it, and add the y component squared. And this will give us a force of 10.11 kilonewtons. And we can find the direction of this force by taking the tangent inverse of the y component divided by the x component. And we'll get an angle that's equal to 8.6 degrees. So we can say that the force AV is equal to 10.11 kilonewtons, which will be at an angle of 8.6 degrees.